we're going to talk about actually like cryptocurrency and the blockchain. So I'll get started actually with the simple definition actually what is blockchain, and then I'll probably start with probably what or probably with a simple scenario with the global payments actually like how a blockchain can help us to transform the way we do business today, or the transform the way we probably do enterprises operate today. Okay. So what is blockchain actually? As we have been hearing, it's the buzzword, and it's like everybody probably like talk of the town, especially the ones who are dealing with actually cryptocurrencies or trading with it. Actually, so I think most of us actually associate blockchain with the cryptocurrencies, and certainly like the Bitcoin is the one actually which introduced the blockchain concepts or the underlying technology actually on which actually Bitcoin was built. Okay, but actually predominantly people associate blockchain actually with Bitcoin, which is wrong. Bitcoin is just a digital currency, or probably is the pseudo currency, or we call it actually virtual currency. What Bitcoin is. Here we are not going to focus just on Bitcoin. We're going to focus on the various aspects of blockchain, how blockchain helps in driving actually the cryptocurrencies, how blockchain helps in driving the enterprises. Welcome to the next generation of internet, actually, as we call it, actually, what blockchain is going to influence, and probably how the blockchain is going to change or transform the way we are on as we probably like do business, or as probably enterprises perform business today. Okay, so this is actually what I'm going to talk through, and probably I'll explain the concepts first before we probably understand what blockchain is. So assuming this is party A, okay, and this is the sender, okay, who wants to send money actually to party B, okay, who is the beneficiary, okay. So in this case, actually, what we are trying to do is, let's say this third party is nothing but actually, let's say Swift, okay, through which actually we're making the payment on, okay, or want to make the payment actually, So this guy is in one geography, and this guy is actually party B is in another geography, okay. So what we do today actually typically in a global payment scenario, let's say this guy, party A, which is like sender, who's sending actually $10 over the network using the third party trusted. It certainly is the trusted party. Could be Swift, could be any wire transfer which you're using to make the transfer through the third party over the network, and the beneficiary would receive, let's say, $9.8 actually, after transfer is done, or the once the money reaches to beneficiary. What is happening here is like this third party actually who's making the transfer, he's doing actually the KYC check at both the ends. Okay, he's doing a KYC check actually both the ends. He's doing actually AML check actually, he's doing AML check. He's doing actually probably he's doing the forex translation actually probably from one currency to other currency to really make from fiat to probably cryptocurrency, or could be the fiat to fiat, to make this transfer happen today actually on the network. And again back to the fiat currency on which actually to the beneficiary to which actually the money would be received. Okay, so if it's a dollar to dollar, fine. Otherwise actually so what he's going to do is he's going to do a KYC check whether this sender actually who's sending the money actually from one bank to the other bank. So he'll ensure probably like he has a valid account, he has an authenticated actually account ID with a valid bank, and do a AML check whether money is fair, it's not anti-money laundering, and plus actually like he might do a forex transfer and all, forex conversion and all before he sends the money from A to B. B is the beneficiary, and he'll do the similar check actually, KYC check actually for party B. He'll do a probably AML check actually for this guy also, and probably at the center side he might do actually validations actually for whether he has a valid bank ID, and whether the bank actually what he's authorized probably is the bank where he's owning the account is an authorized bank or not. Okay, once these validations are done, typically the money gets moved actually between party A to party B. This money transaction actually takes typically 2 to 5 days actually in a real world scenario. This is what actually Swift takes today actually to really make that money transfer happen. So this 2 to 5 days, what the money transfer happens today on the real world scenario. Okay, and there is a probably transaction money which is charged, or administration charge which is charged actually to make this transfer happen. Okay, apart from it, actually once the party A actually probably will have his own bank account. In his bank account, he'll probably have a view probably how much money is being debited actually from his account, and how much money is credited actually to the account of the party B. Will have that view. Okay, so what we are trying to say is probably both these parties have one view or probably in terms of the transaction which is happening. I mean, it's not one view of the transaction which is happening, which means like he'll have actually probably that $10 has been debited, where he'll have a view of $9.8 has been credited. Okay, but he'll never come to know whether $9.8 what reaches to party B. He'll never have that view. Okay, so what blockchain talks about? Blockchain says we don't need a third party to make the transfer happen. We don't need intermediate parties. Okay, what blockchain says? It says actually, you don't have to pay the administration charges to make the transfer happen. So which means if you're trying to make the payment of $10, that party B should also receive the $10 at probably at the other end. That's first thing. Second thing, what the blockchain talks about? Today it takes 2 to 5 days actually to make the transfer happen. Okay, between the two parties. Typically, this transfer can happen actually. If we are talking about Bitcoin network, could be like 10 minutes around what it takes. A Bitcoin network would take. If it's Ethereum, could be 15 odd seconds. If it's like Ripple, it might take up to 4 seconds to make this transfer happen. So that's the kind of speed what we're talking about. So what we call it a near real-time transfers, okay, or near real-time settlements, which blockchain talks about. Or instead of 2 to 5 days, what has been taken on the network. Third thing, what blockchain talks about, the validations which is done manually today, like AML check, KYC check by the third party, it can be automated. Okay, these validations can be automated using any of the programming languages. Okay, if it's depending on the platform what you're using actually for writing your smart contracts. We call them as smart contracts. Basically, you are automating the validations using these smart contracts. So there's a concept smart contract which has been introduced first in the Ethereum, and now it's been like many platforms which are supporting the smart contract concept. Bitcoin didn't have the smart contract concept. Okay, so what we are doing is probably these validations like KYC, AML would be done actually real time on the network. Once these conditions are met, automatically the transfer would happen actually between party A to party B over the network flawlessly in a near real time. And as I said, in Ethereum, it will take 15 seconds. If it's like Ripple, it will take actually like around 4 seconds, and the money would be settled. Okay, and what blockchain says, today we have just a debit entry actually at a sender with the party A or probably the sender end, and beneficiary has actually probably the debit entry. Okay, but there is no way actually where party A or party B or the would have the complete view of in terms of what party A has transferred to party B, or once the money received by party B, party A would come to know that money has been received by party A. Okay, by party B. Party A will never come to know that party B has received the money. That acknowledgement is not happening today on the network. Except that actually you'll be able to see that money has been debited. So what the blockchain says, bringing in actually we have something called as shared ledger technology over a network. So basically now what we are saying is we'll have both the entries actually on the network or on the ledger. Okay, or probably for all the transactions which are happening on the network. So basically we'll have now a debit entry and then a credit entry once the money is received by the party B. Same here, we'll have probably a debit entry, what the party A has sent the money, and then we'll have a credit entry to the party B, actually what the amount has been received by party B. Okay, so that is what actually blockchain brings in. Blockchain brings in more transparency, trust over any transaction which is happening on the network. Transaction happens in near real time. Secondly, I'm like the charges what you pay or the administration charges or the intermediate parties, we don't need the intermediate parties actually on the network to make the transaction happen. That is the whole concept of what blockchain talks about. Okay, so with that intent, I'll probably go back to the our slides actually. So what we had said actually, what is blockchain for? We say blockchain is record the state and ownership of an asset. To make probably what is an asset? An asset is actually anything, any commodity which has a value, which you can transact over a network, is called an asset. Asset could be a tangible or an intangible asset. Okay, what is the tangible? What is intangible? Probably we'll see in the future slide. And it enables parties that do not each other or trust each other to transact efficiently and faithfully. Okay, automate contractual agreements between parties in a network. So if we looked at my example, we talked about AML, KYC check. Those validations which were happening before by the third party, we are actually automating those contractual agreements, those validations which are happening between two parties to make the transaction happen. So why we need blockchain for? What is this blockchain for? This is what the blockchain is for. To record the state and ownership of an asset, enable parties that do not know each other or trust each other to transact efficiently and faithfully, automate contractual agreements between parties in a network. Okay. Components of a blockchain. What is ledger? Ledger is nothing but actually like bookkeeping, record keeping. It basically like maintains the all the records or all the transactions which are happening on a network, business network. Okay. So that is what actually is used. Ledger is used for actually to maintaining actually all sorts of entries is for record keeping or bookkeeping for all the business houses or by the small traders or by actually any industry who deals with commodities to transact. Okay, what is an asset? As I said, actually asset is nothing but a commodity which is shared or which is transacted over a network. Anything which has a value is an asset. Okay, business network. In a business network, actually we have basically different participants which are like-minded who want to transact over a network. Okay, which forms a business network. Okay, what is consensus? Consensus is nothing but basically the value. So see the example which I talked about the global payments. Okay, in that example we had only two participants. Assuming you have a network where you have multiple participants. Okay, what blockchain recommends actually, since we are getting rid of the intermediate parties or intermediary. Okay, we need to have a consensus or something which probably today a federal government or federal agency does it. Okay, which we can trust actually blindly because they have established credibility in the market. To reach to that level, actually we have actually introduced the concept of consensus. Okay, in the blockchain network. So consensus could be achieved actually in terms of proof of work, proof of stake, Byzantine fault tolerance. So there are various other consensus algorithms. How these work actually basically we can define the how the consensus can be achieved on a network. So let's say Bitcoin says like 2/3 of the miners actually has to reach to a consensus before a transaction gets written to a block, and once it's written into a block and agreed upon by all the miners actually on the network, the consensus is achieved. The blocks gets validated and committed to the ledger. Okay, so so consensus is the key to really get rid of the intermediary or intermediate parties or the trusted federated parties actually who helps us in making these transactions over the network. Okay, what is provenance? Provenance is nothing but actually the audit trail of the transactions which are happening. Let's say if I talk about the party A and party B, the transaction actually you will see the same view of entries between the two parties. So today, like if I bring in any auditor or regulator who wants to see all the transactions which are happening on the network, they'll have a common view whether they will review the ledger of party A or a party B. Okay, in the example what I showed you. Okay, so basically provenance is like audit trail or audit history, which will be maintained common across any business network or any business entity or a participant on a network. Okay, so there'll be a common set of transactions which will be visible to both the participants or all the participants on the network. Okay, immutability. Immutability means once a transaction is triggered over a network, okay, it remains temper proof, which means when a transaction is triggered between, let's say, between a sender and a beneficiary in the example what I showed you, the global payments, transaction cannot be overwritten, okay, or it cannot be updated. Only way it can be updated or it can be overwritten is, let's say if I transfer directly $10 from party A to party B, if he returns the money back to the party A, $10 in a goodwill or in good faith, saying that okay, like this money doesn't belong to me, that's the only way you can overwrite. But in that case also, both the transaction entries would be recorded in the ledger. Okay, and hence we call it actually any entries to the ledger or any transactions which are happening over the network are immutable. Okay. Finality. So basically the consensus, provenance, immutability helps in reaching the final state of a transaction, which means once a transaction is triggered, it remains final. Okay, you cannot alter it. And if we have a larger network, we have multiple commodities or there is a journey to a transaction. Okay, we'll talk about what is the journey or transaction life cycle. So basically there is a final state for every transaction and that can be achieved through consensus, provenance and immutability. We'll talk more actually so that you better understand it, what I'm trying to say by finality. So a device for recording the ownership and state of an asset. Okay, as I said, actually ledger is nothing but a bookkeeping or record keeping, what you probably do or transact over a network. Okay, or you record the state of an asset. Okay, what because it changes, the ownership of an asset changes once you when you transact an asset between two parties. Okay, like debit and credit, what we talked about. So this is a traditional ledger actually what we have on the left hand side. This is how probably a different probably entities, probably a general ledger for the sales ledger control account, then for a sales tax, for a sales account, ABC Limited, DEF Limited. These all entities have their own independent ledgers which have been maintained today traditionally on the network. If you see, these ledgers doesn't have any correlation actually between, assuming there are 5 participants on a network, there's just no correlation. Okay, no way you can make out a clear where the asset is exchanging hands. Once is out of probably one's purview. Okay, where actually what we are talking here in blockchain, any transaction which is taking place. So if I say block 0, okay, so any transactions, all the transactions which has happened in a stipulated time are recorded, and all the parties actually on a blockchain will have a common view of all the transactions which is happening between these different participants on the traditional ledger. Okay, which is happening between the different participants on the network. Traditional ledger would look like this, where actually a blockchain ledger would look like this. All the transaction which is happening bundled into a block, and this block gets committed, validated, and committed actually into all the different participants' ledger on the network. Okay, and they'll all have a common view of probably all the transaction which is happening. And why we call it as a blockchain? Because these blocks are interlinked, okay, in such a way that it forms like a linked list, where actually the previous address of the block is stored in the current block. So this, let's say if the block 2 or t plus 2 is the current block, this block would have the previous block hash address. This block will have the previous hash block address. This forms like linked chain, okay, or linked list, and hence the blockchain. It's basically a series of chain of blocks. Hence the name blockchain has arrived. Okay. So what is an asset? Anything that is capable of being owned or controlled to produce value is an asset. As I said, actually two fundamental types of assets what we have. One is tangible, like a house is a tangible asset. Okay, intangible ones is a mortgage. Intangible assets subdivided could be in financial bonds, intellectual patents, okay, or IP is what we call it. Digital could be music and all. Okay, cash is also an asset and has property of anonymity. Okay, I'll move on. So what's a business network? Okay, a business network is nothing but a collection of people and institutions responsible for ownership and a state of one or more assets. Okay, distributed ledgers in a business network synchronized by consensus algorithm. Is that okay? So what is how the asset state changes? Okay, so let's say if you are changing if the asset is exchanging hands between different parties on a business network, certainly the state of the asset is changing, and so because the ownership of the asset is changing. Is that okay? So basically, like asset which was belonging to party A, once the asset exchanges hands between party A to party B, now the asset ownership lies with the party B. Similarly, if it reaches to party C, the asset ownership lies with the party C, and likewise to D. Okay. So what is consensus? So consensus is nothing but attributes that make blockchain a trusted system for managing transactions between parties that do not know each other or even trust each other. Okay. So consensus all parties in a business network agree on the kind of information to be captured about an asset. Okay, so just keep this in mind. Actually, I'll probably talk about it. Actually, like what is the transaction life cycle and how you define these what kind of information an asset can have between two participants, and probably how an asset journey can be defined. Okay, so I'll probably talk about it so that you can relate it better. Provenance parties are able to trace records. As I said, actually auditability, you have actually audit trail of all the transactions which are happening on a network. irrespective of probably like any node actually on the network. So let's say there are hundreds of nodes actually or hundreds of participants on the network. You will have a common view of all the transactions on any node actually on the network. Okay, right from the source or to the root actually like where the transaction has started. Okay, immutability, records in a ledger cannot be altered or removed, which means like temper proof. Once the transaction is committed, stays committed. Only way a transaction can be modified is basically like the party who is the owner, he has to probably like send another transaction to reverse the transaction probably to the original state actually where it belonged to. Okay. Finality, when a transaction is committed, there is no rolling back. I mean, what is the traditional, like, how blockchain will fundamentally change business processes? What is this traditional process actually of traditional business? We have a clearinghouse and intermediate party who helps actually different parties operate and probably share their probably exchange assets using this clearinghouse. Okay, today that's how we typically like probably operate actually in a typical business house or probably typical scenario. Any business scenario if you talk about. Okay, so we have intermediate parties, third parties who are helping with the actually like changing the exchange of the assets in a given world in a given scenario today. Okay, certainly this is not efficient, is very inefficient the way you deal with it, because you're dependent on actually third party to make that happen. Expensive because there's administrative charges or what the intermediate parties are charging, and vulnerable because certainly it's vulnerable because of security or theft. Plus you have actually like it's like a centralized database. Okay, and this database is hacked. All the information actually probably what this guy is owning probably would be would be with the hacker actually who has hacked this system. Okay, because the client server architecture. Whereas in a blockchain we have a distributed systems where each of these parties will have their own databases, and in that case what will happen is like once they have their own databases, even though actually you hack actually one of the systems, probably this system can always be brought back actually with the content or the state of the other parties actually on the network to the original state actually once the system is disconnected actually from the network, and you can restate this network with the new with the current state of the transaction which is happening on the network. Okay, so that's how actually we moving again from traditional to probably like newer way of doing business using blockchain. So how we do business actually over a blockchain? So basically like we have, as I said actually, you can see that probably the different blocks over here: detailed signed encrypted transactions and a ledger. So basically you can see all these parties actually like who are there actually on the network now, they have a common view of all the transaction which is happening on the network. Okay, same blocks are committed actually to all the parties. They have their own distributed systems or distributed databases. They have a common view of the transaction which is happening on the network, and these transactions which are being committed actually on the network, they are digitally signed. Okay, so what is digitally signed? Basically every participant on the network are issued their own identity and access management actually to the network. Okay, basically like if you have heard of PKI, public key infrastructure, so a public key and private key actually, which is issued to all the participants on the network. Public key is made available actually to all the participants actually who are there on the network. Okay, whereas the private key is confidential and is only for the participant actually who should be knowing it, and should be confidential only to the participant actually on the network. And these private keys are typically stored actually onto the wallets, okay, on the network. Okay, and certainly the transactions which are happening on the network is encrypted, we call it hashed, and stored actually on the ledger in the hash form. Okay, all parties have this replicated ledger, that's what I'm trying to say. Okay, there's a single view of ledger actually which all parties have it. Okay, and hence and to achieve the consensus is much more easier, and basically you're not dependent on the intermediate parties. You can probably like have a common view of all the transactions. You can achieve the consensus between all the participants on the network before you commit the transaction onto the ledger by all the participants on the network. Okay, provenance, you have a single view of truth at any node. Actually, if you really go and probably audit, or regulator wants to audit, he'll get a single view of truth at all participants or at nodes, all the nodes actually on the business network. Basically, what all transactions he sees here, he'll see the same set of transactions over here, here, and here. Okay, immutability means like once the transaction is committed, stays as is. You cannot update, you cannot delete a transaction. Okay, is a temper proof. Finality means once the transaction is committed, I mean, the asset cannot change its state. Okay. So basically, with this actually we'll come to what is blockchain. Okay. Now we are going to introduce blockchain in a more refined way. Okay. So let's say if you want to do an elevator pitch, if you are in an elevator, actually, what is blockchain? Somebody asks you. Okay. So blockchain is a trusted distributed ledger with shared business processes. Why we call it a shared business processes? For between two participants on a network. Like if I talk about the example, what we talked about, the global payments, we had a sender and a beneficiary. There are certain actually rules which were supposed to be executed before the transaction would happen on the network. Like we talked about KYC check, AML check, okay, or probably forex exchange before the transaction gets committed between a sender and a beneficiary. So that's what we are saying, with shared business processes, a trusted, a distributed ledger, because both the parties have same view of the ledger and there's a trust between the participants actually on the network, since there's a transparency on the transaction which is happening on the network. So what is a distributed system? A distributed system actually is a system where two or more nodes work with each other in a coordinated fashion in order to achieve a common outcome. Okay. It is modeled in such a way that end users see a single, it sees it as a single logical platform. Okay. So what is a node? Okay. A node can be defined as an individual processing unit in a distributed system. All nodes are capable of sending and receiving messages to and fro, from each other. So distributed ledger technology, blockchain, as we said, actually we call it actually a distributed ledger technology, is a type of data structure which resides across multiple computer devices, generally spread across locations or regions. Why we call that? See, we are dealing with actually global payments. If I talk the example, see, we are talking about probably two people sitting in two different geographies or two different regions and sharing actually probably information or exchanging assets over the business network. Okay, so basically a data structure. Why we call it a data structure? Because there's a common set of information which is stored between the two ledgers or between the two participants' ledgers. Okay, in a structured way, in a structured way. Okay, all the databases actually what it stores, the information which is stored in the database is unstructured. Okay, typically what we use, the DBs actually on the blockchain network. Typically it could be a level DB or couch DB. That's what is probably where the information gets stored. Okay, a distributed ledger technology includes blockchain technologies and smart contracts. While most distributed ledgers existed prior to Bitcoin, the Bitcoin blockchain marks the convergence of host of technologies, including timestamping of transactions. Why we need the timestamp of the transactions? So if you look at it, postmark, probably if you receive letters from the post office, there's a postmark actually against each of the letters, probably a timestamp which is like when the letter has been received. Okay, and so that is what is for every block or every transaction which is committed actually, or probably which is created actually on the network, the timestamp actually which is associated with all the transactions on the network to uniquely identify actually what time this transaction has been executed. So basically that's why we are saying timestamping of transactions. Peer-to-peer network. So we have actually as we say distributed ledger technology. If you see, this is a peer, this is a peer. So basically you can do peer-to-peer communication between two peers using the gossip protocol. Okay, what we have to really communicate between the two peer nodes. Apart from it, you may have actually Google RPC, which we can use. We can use actually NTP protocol, network type protocol, actually to communicate between the different participants on the network. We'll talk about it more in detail actually probably in tomorrow's session actually when we discuss. But for today, actually, just remember actually we have Google and the gossip protocols to convert or to convergence or to probably talk through actually between two peer-to-peer nodes. Okay, and these peer-to-peer nodes, they talk through actually. This is the first concept which was introduced actually into the blockchain with the help of with the convergence of the technologies which Bitcoin introduced. Okay, cryptography. What is cryptography? We talked about public-private key cryptography. Okay, so let's say how many of you have mobile wallets or probably e-wallets? Okay, I'm very sure, like, if you have worked through e-wallets to make the payments, okay, I'm not sure actually, like Paytm or probably any other e-wallets. What we have today is like, you have actually QR code of the merchant actually who you want to make a transfer, okay. That merchant is that QR code is nothing but the public key of that merchant, okay. What you do is you scan the public key of the merchant, you probably do the transaction of the amount what against the commodity or asset what you have purchased actually from that merchant, okay, to settle the balance, and then you enter your OTP or PIN, okay, for the mobile wallet which you are operating on, okay. So this is nothing but public private key cryptography, okay. That is what is cryptography is. Like basically you have a public key of the merchant, you have a public private key of yours, a protocol used to build consensus among participants. So protocols are proof of work, proof of stake, Byzantine fault tolerance. We'll talk about at least some of these algorithms actually in our future slides. Okay, among participants around which transactions will be accepted in what order by the ledger. So the order what in what order actually these transactions would be accepted would be decided based on probably like how we reach to a consensus on a block. Okay, and order of the sequence of probably the way the blocks are formed is the way order of these transactions are probably accepted actually onto the ledger. Okay, so this is what we talked about global payments. Okay, so problems with the current system. Okay, banks and other third parties take fees for transferring fees. That's what we talked about, isn't it? There are administrative charges which have been charged actually today for these certain job functions. What these centralized authorities are doing, like AML, KYC check, and probably some other validations which they are doing, and for that actually they are charging actually that for making those transactions happen. Okay, mediating cost increases transaction cost. So we already see, I'm like, is 20 cents has been charged actually to make the transaction happen. This poor guy is receiving 20 cents less. Okay, minimum practical transaction size is limited because you cannot do n number of transactions because there is a third party who is charging the fee actually for making the transaction happen. Moreover, to make the transaction happen, at least taking quite a long time actually to make the transaction happen. We saw actually 2 to 5 days typically what it takes. Okay, if I talk about Swift actually today have 1 trillion transaction which happens on a daily basis. They have 8,000 plus banks which are enrolled actually on Swift. Okay, so cutting off the possibility for small casual transactions. Okay, basically you will make transactions only when it's really needed and when you don't have an option but to make the transaction happen. Okay, financial exchanges are slow. Checking and low cost wire services take days to complete. That's what we talked about, 2 to 5 days. System is opaque and lack transparency and fairness. So this guy actually who has transferred $10 will never come to know whether $9.8 has been received by party B. Okay, at the end of the transaction. Okay, all he'll know probably his account is debited, but he'll never come to know whether the this guy has received the money or not, and what amount he has received. Okay. Also, the central authority in control can overuse the power and can create money as per their own will. Today he's charging less than 20 cents or probably whatever it is. Tomorrow he can always increase this, probably fee or transaction charges, and nobody can probably oppose it because he already has a big volume of transactions which he's operating and probably transacting in. Okay, so as I said, actually Swift has actually monopoly today in the global payments, and at their whims and fancies, actually like all the banks are operating and probably like in terms of customers, any transaction which are happening globally or probably geographically between one geography to other geography, they have to bear actually in mind actually all the policies or the probably the conditions which are laid out by this centralized governing body. Okay. Okay. So this is actually the problems what we have today in the current system. How we can overcome it? So we need a system actually which eliminates the need of a middleman or third parties, thereby making transaction costs nil or negligible, enhances transaction execution speeds, and facilitate instant reconciliation, is transparent and temper resistant in order to avoid manipulation or misuse. Currency and asset creation is not in control of any central authority, okay, and is regulated to maintain the value of the currency and asset. So this is actually probably a car lease example, traditional business. If you really see, we see actually like all these participants, right from regulator to manufacturer, dealer, lease company, lessee, and scrap merchant, they all have different ledgers. They are all maintaining a different ledgers. If you see, their ledgers are shown in different colors. Okay, so what does signify? Like there's no transparency or trust between the participants actually on this network. Okay, and there's no common view. Okay, and there are certainly third parties actually who are making these transactions happen. Okay, so let's say I'm like, if you see here, these are the third parties. I'm like the governing houses or federal houses or the probably regulators who are actually probably governing these transactions actually happening on the network. Okay, so what is happening today? Let's say sorry. So what is happening today? Actually, if you really see in a car lease example, what happens? You will have. So I'll probably explain you the transaction life cycle. What I was talking about earlier. So what is here actually happening is we have multiple participants. We have actually regulator. So there is a probably what happens today if manufacturer wants to probably manufacture certain cars of certain type, certain make, he'll probably request to the regulator. Regulator would approve that order of that make, that car. Okay, and and he'll issue the unique vehicle identification number. In India, we call it a chassis number. Okay, every vehicle has its own chassis number, isn't it? So this is one transaction, regulator to manufacturer. Once the conditions are met, the transaction happens between regulator to manufacturer. Okay, that's one transaction. Second is between manufacturer and dealer. Okay, so what the manufacturer will say, whether dealer is on-rolled or enrolled actually with the manufacturer, is a trusted dealer, is the dealer relationship is built, and probably is a fair dealer actually, and probably the kind of service what he's giving to its customers. After looking at all these validations, the car would be shipped directly to dealer. This is another transaction, okay, between a dealer and a manufacturer. Okay. Third would be between a lease company and lessee. Between lease company and a dealer. Here in this case, what will happen? He'll check actually probably the lease company, is it enrolled with the dealer? Okay, what kind of relationship it has? Okay, and lease company actually probably gets into a contract with the dealer actually probably that after a certain mileage actually lease company will ensure that the car is probably maintained well at every milestone actually what is achieved. Plus actually it will check actually from the lease records actually lease company records actually what kind of probably what is its authenticity, how it has been performing in the market, what is its credit actually in the market, and before actually the car is shipped to the lease company. And certainly between lease company and lessee, there'll be certain validations which will happen whether lessee like you and me, uh, can he afford a car? Can he really pay the premium or the EMI actually for that car? What is his credit limit? Okay, does he have a valid account? Is it a probably is he a serviceman or a businessman? What is his actually take home actually on a monthly basis? After doing all those checks and validations, actually car would be shipped from lease company to lessee, and then finally from lessee to, once the car is done its period, car would be shipped to the scrap merchant. Okay, which will go to the scrap house. Okay, where car is probably done and dusted. Okay, so this is a typical life cycle of our transaction if you really see it. This is what actually I talked about. If you remember actually one of the slides earlier, um, we say a language of transactions actually distributed ledger that changes the ledger state. So this is what I meant here. Okay, if you really remember actually this is what it meant when I say the language of transactions that changes the state ledger state. So this is what nothing but actually language of transaction. Okay, but in this case, even though this car is changing hands from one entity to other entity, there is no transparency where the asset lies or who owns the asset, because in the traditional ledger we don't have one view of the ledger. Okay, whereas actually in the blockchain, if I go to the next, let's say if I bring then actually one of the network down here, or probably I hack probably the manufacturer node, what will happen actually to lose the complete information, all the transactions and all the information which is stored in this ledger. Okay, and he has to let go that information, and he has to rebuild his probably network. If at all he has a redundancy established, he has a redundant network, he'll be able to bring it up. If not, he will lose actually all the information what was there actually. Okay, that happens. I mean that applies for all the nodes actually on this network. Okay, what does blockchain talks about? Blockchain says shared, replicated, and permission ledger. Okay, the solution to the previous issue. We have actually one view of all the ledger. I mean, all the participants have one view of all the transaction which is happening on the network. Irrespective of the state of the transaction, everybody is getting the same view. So we are saying participants have multiple shared ledgers. Participants, same as before. I mean, participants said nothing but actually the nodes actually on the network. And this is how it helps in reaching the consensus, provenance, immutability, and finality of a transaction. Hope you understand what I mean by finality now. Finality means like there is a one state This is a state for every transaction of, a state, as transaction undergoes as or a state as a asset goes undergoes a state change, and every state change has a final state. Okay, so that's what I meant actually, when I talked about actually, what is a final state or finality means. Okay, so what is means a language of transactions which is happening over a network. An asset state changes and stays that way once the transaction is committed on a network. So that's what I mean by finality. So distributed system actually attempt to solve the problem. Okay, so we had centralized systems, we have decentralized networks, then we have distributed systems or distributed network. Okay, distributed system enables a network of computers to maintain a collective bookkeeping via the internet. This is what we call it. Probably collective bookkeeping means everybody has a trusted distributed ledger technology over a internet. This is open and is not in control of one party, unlike actually in the centralized networks. Okay, it is available in one ledger which is fully distributed across the network. So blockchain use case, okay, and blockchain and use case needs. So what is blockchain? We have understood so far is a trusted distributed ledger technology with the shared business processes, transactions agreed by business participants or business network participants, total clarity of who has done what when, one view of truth shared across business network, disputes easy to resolve because everybody has one common view of all the transactions which are happening on the network. Okay, and in case somebody wants to collude and probably manipulate with the transaction, in spite of that, because of the network size, you'll still be able to probably reach to a consensus saying that okay, this transaction is not valid, and is a colluded transaction or is not unfair transaction. Okay, resilient to failure, fraud. Okay, is that okay? Next one is actually on the blockchain use case needs. So what is a good use case actually for a blockchain? Okay, a good use case would be a business network where we have multiple participants, where we have to establish a trust and bring in transparency between those participants on the network. We have assets to transact. Certainly you need to have something commodity to transact. Okay, without having a commodity or an asset, you don't need a network. Okay, and then you have a transaction life cycle. Okay, or a language of transactions. You don't want probably just there's a one state actually where you want to transact and you want to have a network actually. So basically a good use case would be where there's a language of transactions actually where you want to establish on a blockchain network. Multiple participants to verify the transaction. That's what we say consensus. You don't want actually probably a small network and probably few participants actually reaching to a consensus to verify the transactions. Okay, to know who's done what when, that's transparency is brought in by the blockchain network, because every transaction which is committed onto the network, every participant on the network has the same view in terms of what transaction has been executed, who has executed, when it has been executed, and what probably transaction consists of. Trusted transactions. Why we say trusted transactions? Because transactions are executed through the consensus mechanism. Okay, and these consensus mechanisms are the policies which are set by the participants on the network. Okay, certain rules, governance rules, which are set by the participants on the network. So that's why we say trusted transactions. And single view of truth shared across business network. So basically, everybody has same view of the ledgers or probably all the set of transactions which are happening on the network. That's why we say single view of truth shared across business network. So requirements actually for blockchain for business. Okay, so why we need actually blockchain for business? Okay, certainly first and the foremost benefit is the shared ledger. Append only distributed system of record shared across business network. Privacy, ensuring appropriate visibility, transactions are secured, authenticated and verifiable. Smart contract, business terms embedded in transaction database and executed with transactions. And trust, transactions are endorsed by relevant participants. Broader participation, lower cost and increased efficiency. Okay. Blockchain benefits, we talked about it, saves time. Transaction time actually from days to near real transactions or to near instantaneous, or we call it a near real time. Okay. Removes cost. So we talked about actually, in the case of global payments between party A and party B, we have a third party actually which is charging or intermediate parties which are charging some fees. It removes that overhead, okay, and or probably cost which we are paying towards the intermediaries, okay, to make the transactions happen, okay. Reduces risk compared to if you look at least client server architecture or the centralized databases. Certainly, because of we have distributed systems, tampering is not easy. Okay, it's a tamper proof. Fraud and cybercrime, okay, like it's just next to impossible to really make it happen if the network is set right first time when you set up a blockchain network. Okay, so these are actually some of the industry use cases where all actually blockchain can be implemented, or probably right now the POCs are on. Okay, I'm not saying like this is the only use cases where it can be implemented, but these are some of the use cases where I know actually that their implementations are on. Okay, apart from it, I know aerospace, I know actually telecom, and probably few other industries actually where the use cases are being explored and implementations are being done actually using the blockchain technology. Okay, but these are name a few actually where the implementations are on, or probably implementations are currently being processed or probably being explored. Okay, and even actually process industry like steel, steel processing units and all, like Tata Steel and all. Okay, they're also like some of these use cases are being developed or probably is in the initial stages of it. So types of blockchain. Okay, so I'm very sure like you would have heard or come across public blockchain versus permission blockchains. Okay, so public blockchains are nothing but actually typically like your B2C networks. What we have are typically operating on are typically meant for public blockchains. So let's say if I talk about Paytm, okay, or e-mobile wallets, what we have. Okay, these Paytm wallets actually, if you really look at it, always a centralized client server architecture. Today, I'm like it's a B2C platform. Okay, like anybody can join the network, anybody can drop from the network, and the participants on the network will never come to know how many participants are there on the network. Okay. Similarly, actually in a Bitcoin or Ethereum, okay, which are B2C networks or trading platforms for that matter, okay, B2C networks, you'll never come to know actually who's joining the network, who's dropping the network. Okay. Wherein the permission blockchain, identity is issued and access management is given to all the participants on the network. So I'm not saying in permission blockchain you don't. I mean, sorry, on a public blockchain you don't do that. You do it on a public blockchain also, but the access management is not restricted. Okay, anybody can come and anybody can drop in, and everybody on the network has the view of everything what is happening on the network. Okay, in the sense, all the transactions which are being executed actually on the network on a public blockchain, he'll get all the receipts of all the transactions which are happening and recorded onto the ledger. Wherein permission blockchain, you can probably based on the security of the transactions, you can probably secure some transactions which are actually private for the participants on the network, and few transactions can be made public actually to the participants on the network. Okay, so typically permission blockchains is the solution for enterprise houses, okay, or for B2B customers, whereas public blockchain is the response or answer to the B2C customers. Okay, so a blockchain can be both permissionless like Bitcoin or Ethereum, or permission like the different Hyperledger fabric. A permissionless blockchain is also known as public blockchain because anyone can join the network. A permission blockchain or a private blockchain requires pre-verification of the participating parties within the network, and these parties are usually known to each other. Okay, that's how the difference lies actually between a public and a permission blockchain. Probably we'll understand more when we go through the individual platforms like Bitcoin versus Ethereum versus Hyperledger Fabric. Okay, so typical blockchain workflow. So I'll probably I mean, this is basically like if you imagine Paytm, what you do is actually we talked about. A wants to transfer an asset to B using his smartphone. Okay, to transfer, A will need his private keys and B's public key. So public key is nothing. Let's say like in Paytm, you have a QR code. You scan the QR code. So public key would be shared to all the participants on the network. B shares the public key by scanning the QR code or messaging the service on the app with the A. Once A has the public key of the B, he can transfer the asset to B, which is the cryptographically signed by A's private key. See, you can do the cryptography using either the private key or the public key. Okay. Typically on the blockchain platforms, we do the signing actually using the public key of the participant. Okay. And to see the key pair actually what the no, so B would have a key pair actually. For each public key he'll have a private key. That's what we call it a cryptography. The key pair what he has, he'll be able to view the content of the transactions what has been transferred from A to B. Okay, whereas others on the network will not be able to view it. So once the block is validated, it is added to the shared ledger on a distributed network sequentially based on the timestamp in a way that is consistent and immutable. The consensus mechanism ensures that the validity of the transaction to all participating nodes on the blockchain network. The new block is added in the blockchain network. It's immutable. It's now immutable, ensuring transactions finality. The smart contract gets triggered once predefined conditions like A's proof of ownership of the asset is met. Okay. So this is how typically in a blockchain network, how the transaction workflow happens.